So today we are graphing the last two trig functions, cosecant and secant. Guys. So the way we graph these two is we actually start off by graphing the reciprocal functions. So remember, sine matches up to cosecant, and cosine matches up to secant. And you graph those, and then you graph their, I don't know how I want to phrase this. So depending on like the maximums and minimums of each point on the graph, you graph the inverse. So, what is my reciprocal to cosecant? Sine. So really I want to graph 2 sine x plus pi fourths. That's what I'm going to start off with. Well, that's what we're going to graph by hand, and then we'll do the other part. There's 2 parts to this. Okay, so what is my amplitude? Okay, so that means my y-axis should go up to at least 2. Okay, what is my period? Oh wait, no. Before I do period, I should do phase shift. Phase shift. Because this one has one. So what's my phase shift? Okay, now what's my period? Is there anything in front of the x? So my standard period is 2 pi. Okay. So my key points, I'm going to be taking 2 pi and dividing by 4, because that's my period. And I always divide the period by 4, so this gives me pi halves. That's what I'm counting by. What value do I start at? Whenever I have a phase shift, that's what I start at. If I don't have a phase shift, then I start at 0. And then I keep adding pi halves, so negative pi fourths plus pi halves is pi fourths. Pi fourths plus pi halves is 3 pi over 4. 3 pi fourths plus pi halves. And 5 pi fourths plus pi halves. Okay, so what do I want to do now with my key points? Plot them. So, right now, I'm not plugging into my original equation. I'm plugging into my sine equation. Okay? So then, okay, so what does this one get me? What? So whenever I have cosecant and secant, I start off by graphing their reciprocal functions. And I'll graph those, and then I'll use those graphs to make my actual graph. Okay, 0. Oh, I forgot to label this. What do you want me to count by? On my x-axis. Okay, pi fourths. Okay, so then the next point I want to plug in is positive pi fourths. So what do I get here? Should get 2. So I'm going to plug in my next point, which is 3 pi fourths. Oh, wait, I plotted my first point wrong. Because I plugged in negative pi fourths. Well, you guys aren't writing in pen like me, are you? Oh. You're not typing your pies. Okay. So what do I get when I plug in 3 pi fourths? No. 0. Ah, 3 pi fourths, not pi halves. Okay. Then I want to go do the same thing for 5 pi fourths. Because I keep plotting points that I don't mean to when I'm writing in pen. Because I didn't plug in pi halves, I plugged in 3 pi fourths. I didn't plug in 0, I plugged in negative pi fourths. Yeah. It's a Monday. You know. Then I want to go ahead and plug in 7 pi fourths. What does 7 pi fourths give us? 0. This one is a little off my graph. So then I want to go ahead and connect these points. And I know I wrote negative 2 pi to 2 pi, but I'm just going to graph what I can see. Okay. So then what I want to do next after I've graphed sine, because remember this real equation was not to graph sine, it was to graph cosecant, is I am going to draw asymptotes where y equals 0. So everywhere I have y equaling 0, I'm going to draw an asymptote. Okay, then what I'm going to do at the maximum and minimums, draw How do I want to phrase this? Okay, so at my maximums and minimums, what I'm going to do is I'm going to flip the direction they're going at their vertex. So I'll give you a second to write that, and then I'll show you what I mean. It's just adding like 2 more steps. Okay, so here, in between my asymptotes, I'm going to curve this, so now it is curving down. And then over here, instead of being a maximum, it's now going to be a minimum. And same thing over here. I just want to draw these in between my asymptotes, going the opposite way. So my real graph that I care about for my answer is the one I've just drawn in blue. But I need all that work in red to show how I got that blue one. Okay, so the next one we're going to look at is sketching the graph of secant. This one is the reciprocal function of which trig function? Cosine. So I want to start off by graphing cosine 2x. So what is my amplitude here? 1. Is there a phase shift? No, there's nothing being added or subtracted to that 2x inside parentheses. Period. Is there a coefficient in front of that x? Yes, so I'm going to take 2 pi and divide by that coefficient, which is 2. So my period here is pi. Then I want to go figure out my key points. So I always take my period and divide by 4. So this time I'm doing pi divided by 4. Yeah? Yeah, so whatever the number in front of x is goes on the bottom of the fraction. So like if it was like a 1/2, I would have 2 pi divided by 1/2. Okay. Then what is my starting value for my key points? So I don't have a phase shift, I start at 0. Okay. Then I want to count by the pi force. So 0 plus pi force gets me, pi force plus pi force gets me, what's 1/4 plus 1/4? Pi halves. Pi halves plus pi force? 3 pi force. 3 pi force plus pi force? Okay. So these ones I am plugging into the cosine function. So I'm going to have cosine of 2 times 0. Oh wait, I forgot to label my graph. We'll do that in a second. Cosine of 2 times 0 is 1. So I need to label this so I can graph that point. My amplitude is 1, so my scale doesn't really matter here. I just need to have a scale for my y-axis. What do you want me to count by on the x-axis? Okay, pi force. So this interval right here is telling me where I want to graph between. I want to be between negative 3/4 and positive 5/4 when I go ahead and graph this all. And then I can go ahead and finally graph the point I plugged in. When I plugged in 0, I got 1 out. So I'm going to plot that. Then I want to go ahead and plug in pi-force. Okay. What do I get when I plug in pi-force? No. 0. Remember, it's 2 times pi-force that you're typing in the calculator. Okay. So then I go ahead and plot this point. Then I'm going to go ahead and do the same thing for pi-halves. What do I get when I type in pi-halves? -1. Then 3/4. And pi. One. So then I just want to go ahead and extend to my interval. So actually let me connect these points first. So going to 5/4, 5 pi-4 would go back down to 0. And then I just want to move this over to the left. Ideally, your curve should be curvier than mine. Okay, so then, just like with the cosecant, I want to draw asymptotes where my y equals 0. Okay. Then I'm going to go ahead and flip those curves. So everything I just drew in blue is my answer here.